What comes to mind when I say the word cryptography? Solving a near impossible cipher to unlock a clue in a mystery? Well, that's part of it. According to Wikipedia, cryptography is the practice and study of techniques for secure communications in the presence of adversarial behavior. In the last video, I introduced you to the SSH protocol, and cryptography is central to the protocol and the reason it replaced Telnet and RLogin. When I talk about cryptography in respect to SSH, I'm talking about the encryption used to secure it, the encryption used to authenticate users, and the hashing that makes sure no funny business is going on with the transmitted data. This is B from Talk Tech, and today I'm going to tell you all about the cryptography involved in SSH, so stick with me. I have a favor to ask. If you like this type of video and want to see more content like it, make sure you are subscribed and hit the bell button for notifications. Also, don't forget to give this video a like if you like it. Let me know what you liked, didn't like, or if you have any comments, questions, concerns, or emotional outbursts down in the comment section below. And lastly, make sure you stick around all the way to the end of the video to get the most out of it. Let's do this thing. But first off, we have Tessie joining us again. Say hi, Tessie. 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 You don't want to say hi to the camera? All right, well, guess we're going to have to move on without saying hi to Tessie, but she's right there if you want to say hi to her. But yeah, moving on to the cryptography overview. Now, we're going to be talking about three different pieces of cryptography. We're going to be talking about symmetric encryption, asymmetric encryption, as well as hashing. All right, so I'm only going to be covering these briefly in this video just to give you some context. If these are something that you'd like me to cover in more detail in a future video, please let me know down in the comment section below. All right, so the first one we want to talk about is symmetric encryption. So essentially what's happening with symmetric encryption is the same key is being used to encrypt and decrypt data. This is actually, let me shrink my face down because I've actually got a, whoops. Actually got a visual here for you. All right. All right, so yeah. The same key is going to be used to encrypt and decrypt the data. This is like the key to your house. You're going to use that key to unlock it and relock the door. This is also known as a shared secret. And then in the context of SSH, this will actually be known as like the session key. And then this is actually used to encrypt the actual SSH data or to create the SSH tunnel between the SSH client and the SSH server. And here we can actually see an example of symmetric encryption. So here we have our SSH client, we have the SSH server, and we can see that they both have a purple key, which signifies that they have the same key, and the message is hello, and it's encrypted with this purple key, and it's the gobbledygook is right here, and then it is decrypted with the same purple key, and it is now hello again. So that is symmetric encryption, so one single key. Now, asymmetric encryption is a little bit more challenging to get your head wrapped around. It's a little funky. And I remember when I first learned about asymmetric encryption, it's also known as public key cryptography. But let me just go ahead and just kind of give you an explanation, and I'll also be able to give you a visual on it. But with asymmetric encryption, this involves a private key only you know and a public key anyone can access. They're what's known as a key pair. These keys are different but are connected when they are created. One thing you'll never want to do is share your private key with anyone. The public key is like your public persona. Like it's what you show to the world, what you share with the world. And then the private key is like your deepest, darkest secret that you don't want to share with anybody, but still is a part of you and is going to be part of the way that you make determinations and stuff like that. So that's the kind of way that I like to think of it. This is, again, also known as public key cryptography, and this is actually going to be used for the authentication in SSH. So let me go ahead and switch over here. Now, here we go. So here we're talking about the public and private key from the perspective of the SSH server. So you're still the SSH client. So what would happen here is you want to go ahead and send some encrypted data to the SSH server. So then what it's going to do is we're going to go ahead and take that data, which is hello. We're going to encrypt it with their public key. And then we're going to go ahead and send it over to them because here's the gobbledygook that is the encrypted text, the cipher text, if you will. And then we're going to go ahead and send that over to the server. And now the server can go ahead and decrypt it because it has the public key. Now, the reason that this works, these are two separate keys. They are related to one another, but they are different. And the reason that they are able to go ahead and do this is because they're created at the same time. And then they're both being associated with that SSH server. So because of that public key, is associated with that SSH server, the only person who can be associated with that public key is going to be the holder of that private key. So that's how it's going to be used for authentication. It's like, hey, I've got this thing right here that can only belong to Brandon, to B, right? This one thing. Well, that's going to be the public key, right? But then I have it right here, the thing that shows that I am indeed me. So these right here match up together. So, because they're both associated with the SSH server, or in this case myself, like my public key and then my private key, that's how we're going to be able to go ahead and authenticate. Now, it's used in other forms and fashions and stuff like that, especially like when we start talking about TLS and things like that, but that's something that's totally different. Now, and with asymmetric encryption, as far as SSH goes, it's only going to be used during the setup of the actual connection, the SSH connection. So just keep that in mind. Now, let's go ahead and move on to hashing. Hashing is a one-way function that is used to ensure that data has not changed in transit. So when you hash something, you should always get the same value unless something has changed. So if you hash something and you're given something that is hashed, and then they give you a hash of that thing that was hashed, and then you run the calculations on that hash data, and you get something that's different, that's going to tell you that something has changed, and that is not indeed what that is. So it's really what it's used for. It's used for integrity of data. And this is what we're seeing here. So, and it's a one-way function. You should, once you hash something, you cannot unhash it back to what it is. You can use it to authenticate that it is correct, but you can't. They use this like in password storage and other uses and stuff like that. But here we go. We've got our SSH client. It's going to take hello. It's going to hash it. Let's just say this is SHA-256, which is a very common hashing algorithm. And then it's going to go ahead and get this ciphertext down here, or this hash down here. And if we were to go ahead and run this hash, we would go ahead and get the corresponding hello. So easy enough. So now let's go ahead and actually talk about cryptography in SSH. So what I'm going to go ahead and do here is I'm going to go ahead and switch over to my virtual machine here. Let me clear this out. I was doing some work on it. All right, so how it's going to start is when we're talking about SSH is the client is going to initiate, and actually, you know what? No. I want to do something different here. So bear with me here for just a second. I pulled something up here just for this. Let me see if I still have it. I might have to pull it back up. That's okay if I have to. There we go. Let's go ahead and come down here. There we go. All right, so here we go. And I'm sorry if this is a little hard to see. Let me see if I can make this bigger. I'm not sure. Okay. There we go. Here we go. We're using actually Wireshark. And what I did is I went ahead and did a capture on an SSH connection. So I'm going to go ahead and filter it by SSH connection. And I wanted to go ahead and actually be able to give this to you in context of an actual SSH connection that's happening. So the first thing that's going to happen is the client is going to initiate the SSH connection with the SSH server, and they exchange SSH protocol version and software version. So that's going to be what's happening right here. And you can actually see who's doing what. So we see client, server, client, server, client, server, client. So this is where we want to start here, is this one right here. So we're going to go down here to SSH protocol. And here we can see that this one has SSH 2.0, which is the current version of SSH. And then it's running the software version of OpenSSH 9.0. That's my Mac. And then here is my home server, which is running a little bit older version, which is OpenSSH 8.7. So they're not too far off. So they're basically right now saying, hey, they're introducing themselves. They're saying, okay, like this is what I've got here. At this point, the server will also provide its public key, which you're not actually seeing here, but it will provide that. The client is going to store that public key in its known host file, which I can actually show you here. All right, and wait, what is going on here? What happened here? That's weird. Okay, so we're going to clear this one out because for some reason my Debian system decided that it was going to suspend now. I don't know what's going on there. So let's go ahead and go back over here. we're gonna do is this is my home server. I can use this one as well, but I do have it here. So what we're gonna do is we're gonna do a cat. We're gonna do period SSH, and then we're gonna go ahead and do known host. And you have two of them. We only want the current known host one, and we're just gonna go ahead and do that. We can see all of these right here. These are all the known hosts and their public keys. This is going to be saved on your system in this file, because what it wants to do is it wants to help make sure that you're connecting to the correct server in the future. Because if you say if somebody did some funny business and did some is impersonating the server, when you come back and you're like, oh, this public key is not the right one. This is not the same person. Not the same server. So it's going to help alert you to some kind of change like that. Now, let's go ahead and go back. Now, the next thing that's going to happen is it's going to be the client and server are going to negotiate encryption, key exchange, and hashing protocols. And for whatever reason, it's not showing all of those in here, because it does show the encryption right here, which is this one right here, which is this cha-cha-20. It doesn't actually have any compression, but it should be happening. It's just not showing it, and that just may be something funky with Wireshark, or maybe it just doesn't. Maybe they've changed. Maybe they've updated the like the actual what actually shows inside of the packet and stuff like that. But we can actually see that right here. Is it's going to have. They're going to be using cha-cha-20, and then I think that's what it's called. That's actually not one that I'm familiar with, so if I'm saying that wrong, please let me know in the comment section below. But it's also going to list in here the actual algorithms that they support. If you come down here, go to key exchange and go to algorithms, we can see here these are all the algorithms that it supports, and this is going to be for encryption, key exchange, which is KEX, and then the MAC, which is going to be the hashing. And then it's also got compression algorithms and all that good stuff. But yeah, we know that it's going to be using this right here. And the key, it's going to be using this for encryption. It's going to be using this for key exchange right here. All right, so that, and then we can see something very similar on the server side. You can see all that right here. Yeah, and they what they're going to need to do is they are going to need to share an encryption algorithm in common, which is what you're seeing here. So if you actually look at these, I'm just gonna put this out. Is when we're talking about the encryption, we're talking about this right here. We can see that the encryption one is the same for both. So they're going to be able to successfully make this connection and be able to go ahead and do the negotiation, because if not, it's going to fail. And basically what's going to happen is that they're going to have a list of them going from their most preferred to their least preferred, and the most preferred will be the one at the top. Now, let me actually show you something here. Let's go and clear this out. We're going to do SSH, we're going to do Q, and then we're going to go ahead and do cipher. And this will let us know all of the encryption ciphers that are available. All right, we can see the one right here. Reason for this one. All right, let's clear this one out. We're going to do the same thing, but we're going to go ahead and do it for KEX, which for key exchange. All right, and there we go. And then what was the one for this one? I can't remember. Let's see. Key exchange method curve 25519. There we go. Was it the one with the SHA-256? Yeah, this one right here is the one that's actually using for it. So we can see that they're actually directly from the list. So we can see the encryption cipher, we can see the key exchange algorithm. The one that we're having trouble seeing is the message authentication code. We can also see those here. Let's clear this out. I'm just going to do SSH. Do that, and then we're going to do MAC, and that's going to give all of those right here. I want to check something. I want to make sure that I'm just not missing it somewhere. Somebody may be like yelling at the screen, being like, "Dude, it's like right there," or something like that. Key exchange. Yeah, see, I just don't see it here. Because this one right here is hashing algorithms. Those ones look like it's truncated ones. And all that stuff, at least as far as hash. And then it's got this one right here, but I don't think that's one of them. No, see, it's not. But that's okay. Like, we know that it's doing it, and that's the important thing. But yeah, so we understand what it's doing here. And then the last thing is it's going to actually use the Diffie-Hellman algorithm, which is an asymmetric algorithm. to generate and exchange the session key, which is what's happening right here. This is our client initiating it over to the server. The server is actually going to be the one who will generate the session key and send it back to us. Now that session key is that asymmetric key. I'm sorry, the symmetric key, which is going to be the one that all of the data is going to be encrypted through. So it actually generates it through here, and we can actually see where it's. I believe you should be able to see it here. Maybe not. Yeah, see, we can see the key exchange here. It's using, here's the ephemeral key. Because again, these are only used for this session. But yeah, see, it's not going to actually put the key in here, but yeah, see, and here's the key exchange method and all that stuff, and it uses like some crazy stuff. I'm actually going to put an article down in the comment section below that we'll be able to go ahead and kind of give it to you a little bit more in detail, exactly how these things are generated, just because it takes away a lot, and I don't want to spend 15-20 minutes going over just those two things when there's a nice article that can help sum that up. But yeah, and then yeah, the session key will be used to encrypt all the traffic for the remainder of the session. Man, that was a lot of information, and I'm hoping that you have a better understanding of the cryptography involved in SSH. Make sure to check out the previous video on SSH, or if you're caught up, check out this other video instead. Remember, mistakes make you better, so keep on making them. Thank you so much for watching my video, and have the greatest of days.